Okay, so in the next video we talk about integer programming, and that is a situation when we need to require a solution which is an integer and not some fraction. And that is just a minor adjustment or a minor modification to what we already know. So let's consider the following example. So integer programming is concerned with cases when fractional solutions are not feasible. So consider the following example. Let's say Magic Cookies produces chocolate and vanilla cookies. And the chocolate cookie sells for 2, so let's say that's the unit profit, and a vanilla cookie for 1. So then the production of cookies requires eggs, flour, chocolate, and vanilla. And the following table summarizes the required units of each input factor for a chocolate and a vanilla cookie. So at this point, I think we already have the skills to just derive the solution or by using solver and program it in Excel. So let's just go over the steps again. We start with decision variables. So our decision variables are chocolate cookies, and vanilla cookies. And then we have again the unit profit. Actually, we had first optimal quantities, and the unit profit. You could change those two rows, it wouldn't make a big difference. So unit profits. So again, these two cells, C2 and D2, they will be filled again by Excel. So we can make that later, we can format that later. And the unit profits is a chocolate cookie is 2 and a vanilla cookie is 1. So then we go to the constraints. I just copy that quickly from here. And we have eggs, flour, chocolate powder, and vanilla powder. So we can just copy this table quickly. 1, 5, 1, 0, 2, 5, 0, 1, 2, 5, 0, 1. Then we create a column with the total usage. And now I can zoom in here. Maybe I go here to the corner. So the total usage, we have to enter the formula. We need the sign and the max available. Okay, so let's start on some formatting issues so that it looks nice. So the optimum quantities, that will be an output by Excel. The unit profits, that is something that we need to input, and the production coefficients is something that we need to input as well. Okay, so then we need the formula for the total profit. And the formula is equal to the optimum quantity of chocolate cookies times the unit profit per chocolate cookie plus the optimum quantity for vanilla cookie times the unit profit. Okay, so that is maybe a calculation again. Then the total usage is a calculation. Okay, so now instead of entering the total usage manually by saying, okay, the optimum quantity times the number of eggs per chocolate cookie plus the optimum vanilla cookie times the eggs used per vanilla cookie. So let's say I just enter 3 and 4. So entering the way I entered it right now, it's a little bit cumbersome, can be a little bit simplified, and there is something which is called sum product. So you see we had here 11, and if we do sum product, and we have here that array, and highlight the second array here, then what it happens is it takes the sum of the product of this times this, 3 times 1 plus 4 times 2. And then I can fix the first row, and then I just can copy down that formula. And then you see it multiplies 3 times 0 plus 4 times 1 equals 4. So sum product is a useful formula. So that is also a calculation. Then the sign is always less than or equal. Let's copy this down. And the maximum available, I still need to look that up. 20,199. 20,199. And that is also an input. Okay. So now we have everything, but I also want to make it again interactive. So the x-axis I can tell, let's go back to 0 and 0 here first. So 20 to 20, maybe let's do again 30 should be enough. And let's see how we did it in the lecture slides. So, okay. So when we draw it, we have the vanilla cookies on the x-axis, okay? And in the slides, we go till 20. Okay, so let's go till 20. Let's replicate what we have in the slides. So the x-axis will be the vanilla cookies. And that is equal, it starts at 0 and then it ends at 20. So we use the command home fill series. Okay, so now the constraints is x. So what we try to do is, when we have all our constraints, we try to generate something in Excel which looks like this. So on the x-axis we have the vanilla cookies, and here we have the chocolate cookies, and we want to draw our constraints, and we have eggs, flour, and chocolate powder and vanilla powder. They are a little bit different. I just called it choc powder, vanilla powder. So they're a little bit different in the sense that we don't have more than 9 units of chocolate powder, so that means we have to have here a horizontal line for chocolate powder, and for vanilla powder the limit is a vertical line. So that would be vanilla powder. And eggs and flour are negatively sloped. Okay, so let's just do that again, and we already know from before, from the earlier video, that if we want to make that fully responsive, the x constraint is the maximum available. So now, so the intercept will be, so now we have to divide by, so we look at the intercept, right? And so we have to take a maximum available and divide it by the chocolate cookie in this case. So that will start at 20, so we have to F4 that one. And then we divide, oops, let's do it again. So the 20, okay, F4 divided by chocolate cookie. So the intercept will be here 20 minus the number of vanilla cookies divided by, not the number, the coefficient, production coefficient. Now we put again F4 times vanilla. So that should give us an intercept of 20 and intersect at 10. So that's correct. And again, we want to avoid negative values, so we say if the equation that I just entered evaluates to less than 0, then enter hashtag n\a and otherwise use this formula. So I copy the formula to the else condition. And now all the negative values disappear. So now for the flour constraint, so we have a total of 100. So again, we start by taking the maximum available, divide by the coefficient for the chocolate cookies, then we divide by the ratio of the vanilla cookies coefficient, divide by again, so we take the vanilla cookie coefficient and divide by the chocolate cookie coefficient times cell B12 where we have the quantity for the vanilla cookies. Okay, so now we put again an if around. If this evaluates to less than 0, then comma, but then is the comma in the Excel formula means then number and a, else, or if the value is false, we just use this formula. Okay, now we can copy this down. Where we show, if you see something like this, you can be sure I forgot somewhere the dollar signs to fix the formula. So let's go back. Okay. Well, there is a B12, that's the problem. I mean, there's a B1 at the end, so I forgot. Okay, so now that looks correct. So I accidentally deleted the 2 from the B12. So it was actually another problem related to the dollar signs. So now we set the chocolate powder, well, it's always 9. Okay, it's always 9. So that will be the horizontal line. And for the vanilla powder, if we want to draw that, we basically need to have a column here. And we need to have a column at 9. So I enter everywhere an NA, except for on the x-axis at the value of 9, I want here a column, and maybe that column shall go up to, let's say, 20. Then I also want to have an ISO profit line. We can also do the feasible production. And the ISO profit. And at this point I can delete all the ink in that sheet. Okay, so the area of feasible production is always the minimum. So if I do this, I get an A, so I need to just limit it to the minimum of chocolate powder, flour, and eggs. Copy down the formula, and then the ISO profit line is again derived from the total profit, which is the unit profit of the chocolate cookie times the amount of chocolate plus the unit profit of vanilla times vanilla. So now, because we want to have on the y-axis the chocolate cookies, so we have to solve for chocolate cookies. So that is unit profit chocolate times chocolate equals total profit minus unit profit vanilla times vanilla. Then we divide both sides by the unit profit of chocolate, and then we get the total over the unit profit of chocolate minus the slope, which is given by the unit profit of vanilla over the unit profit of chocolate times vanilla. So that means that is equal to the total profit, which we get from solver. Then we divide by the unit profit of chocolate minus the unit profit, oops, I made a mistake, that is unit profit, okay, now it's correct, minus the unit profit of vanilla cookies divided by the unit profit of the chocolate cookie times number of vanilla cookies. Okay, and again I just make sure that we don't have any negative values, so I put around the formula an if command. If that formula evaluates to less than 0, punch into return an A, otherwise use this formula. Very sure now I forgot something again. No, I didn't, because we have here 0, 0, but let's say if you get, I don't know, 5 and 5, we get values here. Okay. Okay, so let's delete again all the ink. And what we can do now is we can actually run solver on this problem set. So we go to data, solver. Okay, so now our objective function that we max is total profit. We want to change these values that currently say 0. And now we use the constraints. Total usage has to be less than the maximum available, and I use the shortcut, okay. And again, we want simplex. So that should be it. And now we should see the optimum solution. Okay, so you see now the problem is that we will get 5.5 vanilla cookies, but we can sell half a vanilla cookie. So we need an integer solution. So let's take a look at what our problem looks like. So let me draw that fully responsive graph. So we highlight the data array, go to insert, recommend the chart, then I typically go to line, and then it's the second from the left, and let's put that maybe let me go out of the way. Okay, so let's make that nicer, and let's see what's going on. So we do first increase the major units, actually decrease it to 1 so we can see better, and then maybe add grid lines. The vertical are still missing, so, and let's do again a combo chart. So change chart type to combo. So the X constraint, that should be a line. The flower constraint should be a line. The chocolate powder constraint should be a line, but we said the vanilla powder constraint, that should be a column, and the feasible production, that's an area. Okay, and the ISO profit is a line. And you can see again that the values are displayed between the categories, which are actually the x-axis numbers. So we can change that by format axis, go to on tick marks. And so what we have here is, let's take the ISO profit line and let's make that black and highlighted. I mean, turn it into dashes. Okay. Oh, and here the area of feasible production went beyond the 9, so that shouldn't be the case. So we can manually fix this here. So let's just put here an NA as well. So again on the x-axis we have the vanilla powder. Let's add the axis title. So here we have chocolate, on the x-axis the vanilla. So now what did Excel give us? Maybe I can zoom in here a little bit. Let's see what happens. Okay, so if we zoom in here, we see that Excel says, okay, the optimum number is 9 chocolate cookies, but we are between, let's make that transparent here. Let's maybe give it a light gray. But we can see that for the optimum solution for the vanilla cookie is between 5 and 6. So now if you want to manually find out if we use an integer solution, what happens is I can quickly insert here a shape which has exactly the same slope as the current isoprofit line, which generates a solution which is not feasible because we can't sell half. So if you see it here, it should be pretty clear that the isoprofit line will generate a solution which is here at 5.5. So what we can do is, we know that we get the optimum if we shift the isoprofit line as far out to the right as possible. And so I could actually produce 8 chocolate cookies and 6 vanilla. So that would be one option, right? This point here, that would be one option. But the other option would be a little bit further out, which is actually to produce 9 and 5. So that is what we should expect. So let me delete again this auxiliary line. So what we should expect is actually this one here, which is 9 and 6. So let's zoom in again a little bit. So this is what we should expect. And let me quickly delete again all that ink. So how do we tell Excel that we want an integer solution? And the answer is very simple. We just go to Data, Solver, and then we just add a condition. We just say add. And then we say those two cells, 9 and 5.5, they should be equal to, and then, I'm sorry, it should be here in the middle. You say it's where it says equal, it just says integer. That's it. And now if you click OK, the optimum solution should be 9 and 6. So let's double check what we get. Okay, so solve. This is still correct, C3. By changing these values. It's actually 9 and 5, I'm sorry, and it was the correct solution. It's at 9 and 6, but 9 and 5. So let's just double check again. So we said we have two options. So let's go back again and insert a line, which we can shift. Okay, and we said, okay, we have here one solution, which is here. That's the optimum, which is 9 and 5. Well, the other one would be, the next integer solution would be 8 and 6, but that wouldn't be the optimum. And we can easily check, so 9 and 5, you can also visualize that. So why wouldn't 8 and 6 work? So now our total profit is 23, but with 8 and 6, which is also feasible, it's only 22. So the correct answer is, for an integer solution, 9 and 5. So one last time to restore it. And now you see the only thing you also get is an answer report. Excel doesn't give you the option for a sensitivity report or a limits report. So that is an option that disappears in Excel. So all we have is getting an integer solution. But it's not that difficult. It's just like a slight modification that we did earlier. In the earlier example with our toys, we already, let's just run it again, solve, keep. In the previous example, we already had by default a integer solution that wasn't a problem. But here we need to restore one, because if we don't tell it integer, it will give us a fractional solution which we can't use. Okay, so that is about integer programming, and let's just stop here and then move on with another special case which is known as 0-1 programming, but which is basically the same idea. Okay, so I'll see you in the next video.